Therefore, the total number of parallelograms that can be formed with set of 5 parallel lines intersecting another 6 set of parallel lines is totally 150. 2 lecturers who were conveners last year have to be included, and 3 boys who failed in the examination cannot be included. So that means 3 boys cannot be chosen. If we select 7 boys and 4 girls, 8C7 into 7C4, that's equal to 8 into 35. Totally 392 plus 588 plus 280, that's equal to 1260 beds. Hello dear students, welcome to this session of basic mathematics class. I am Mr. Niranjan, faculty Department of Mathematics, Vidhyaashram PU College, the Temple of Excellence. So in my previous class we have discussed regarding the combinations and the properties of combination and important formulas and the problems based on these important formulas, right? So in this session I am going to discuss regarding problems based on NCR and the geometrical formation using the combinations, the problems based on NCR, as well as the problems based on a geometrical formation using the combinations. Now straight away move to the first problem. Find the total number of parallelograms that can be formed from a set of 5 parallel lines, intersecting another set of 6 parallel lines. So here we have to find the total number of parallelograms. What is the condition? That can be formed from set of 5 parallel lines, intersecting another set of 6 parallel lines. So 5 set of parallel lines are intersecting with another 6 set of parallel lines. If such is the case, how many parallelograms that can be drawn from these 5 lines as well as the 6 lines? This is the problem. Very simple and very important problem, right? So to draw a line, minimum number of points required is 2. 2 points are required. Suppose let us assume this is a diagonal. Then here how many points are required to draw a diagonal? Minimum 2 points are required to draw a diagonal, right? Now let us consider the first condition, 5 parallel lines. Let us consider M as 5, and the second intersecting lines are N is equal to 6 parallel lines. Now let us see how many parallel lines are there. Are 5 parallel lines and 6 parallel lines. So these 5 parallel lines and 6 parallel lines can be used to construct a parallelogram. So the required combination is, so first 5C2 into 6C2. That's all. Because so to draw a diagonal, minimum 2 points are required. From 5 pair of lines we are going to write 5C2 ways, and from 6 parallel lines we are going to write in 6C2 ways. So therefore the required combination is 5C2 into 6C2, that's equal to 5 factorial divided by 2 factorial into 5 minus 2 factorial. Let me write 6 factorial divided by 2 factorial into 6 minus 2. What is this equal to? Factorial 5 divided by factorial 2 into factorial 3 into factorial 6 divided by factorial 2 into factorial 4. So this is equal to, so factorial 4 is 5 into 4 into factorial 3 divided by 2 into factorial 3 into factorial 6 into 5 into 4 factorial divided by 2 into factorial 4. So this 4 gets cancelled, 2 3s gets cancelled, 3 gets cancelled, 2 4s. So what is the required answer? 5 into 2 into 3 into 5. So 5 2s are 10 into 5 3s are 15, that's equal to 150. So therefore the total number of parallelograms that can be formed with set of 5 parallel lines intersecting another 6 set of parallel lines is totally 150. So we are going to write 150 parallelograms. That's it. Very simple problem for 3 marks. Hope you followed. Now move on to the next problem. Find the number of diagonals in a decagon. Let me explain. Let me read the problem. Let us move on to the next problem. Find the number of diagonals of a decagon. Number of diagonals. Here also to write a diagonal, minimum 2 points are required. Minimum 2 points are required to write a diagonal, right? So here find the number of diagonals in a decagon. Very simple problem for 2 marks. Okay. So decagon means here the number of sides n is equal to 10. So there is a formula for this. The number of diagonals is equal to nc2 minus n. What is n here? N is equal to 10 c2 minus 10. That's all. 10 c2 minus 10 will give the number of diagonals of a decagon. Okay. Simplify this. Now what is 10 c2? 10 c2 minus 10. 10 c2 minus 10 can be written as factorial 10 divided by 2 factorial into 10 minus 2 is 8 factorial minus 10. So this is 10 into 9 into factorial 8 divided by 2 into factorial 8 minus 10. These two gets cancelled. 2 5s are, that's equal to 9 into 5, 45 minus 10, that's equal to 35. So the number of diagonals that can be drawn in a decagon is 35. That's it. Okay. Now move on to the next problem. In a party, each person shakes hands with everyone else. If there are 25 members in the party, calculate the number of handshakes. So in a party, each person shakes hands with everyone. So if there are 25 members in the party, calculate the number of handshakes we are going to calculate. Okay. Here. So just to shake a hand, so 2 persons are required. We cannot shake our hand with ourselves. So therefore there are 2 persons must be required, right? So here number of persons, what is, how many given? If there are 25 members in the party, calculate the number of handshakes. Okay. Now here 25 persons are there. For the number of general formula for number of handshakes is equal to number of handshakes is equal to nc2. Here how many persons are there? There are 25 c2. Just find out the value of 25 c2. That's all. So 25 c2 can be written as 25 factorial divided by 2 factorial into 25 minus 2 is 23 factorial. That is 25 into 24 into factorial 23 divided by 2 into factorial 23 gets cancelled. So this is 25. Divide 24 by 12. So 12 2s are 24. So 25 into 12. So 25 into 12 is nothing but 300. So the number of handshakes is equal to 300. That's it. Now listen, very simple problem. Here in a party, each person shakes hands with everyone else. If there are 25 members in the party, calculate the number of handshakes. So here minimum there is one formula. The number of handshakes is always equal to nc2. What is given here? N is equal to 25. Just find out the value of 25 c2. 25 c2 is nothing but 25 factorial divided by 2 into 23 factorial. That's equal to 25 into 24 divided by 2 is 25 into 12. That's equal to 300 handshakes. Now move on to the next problem. I'll do this problem once again. Now let us move on to the next problem. A team of 8 players has to be selected from 14 players. In how many ways the selection can be made if there are 2 conditions? First condition, but 2 particular players are included and 2 particular players are not excluded. If 2 particular players are included and 2 particular players are not included, that is excluded. Not included means excluded. 2 particular players are excluded. So let us go to the first case. 2 particular players are included. How many players are there? 14 players, out of which we are going to take 8 players. So if 2 particular players are included, then that means the number of arrangement will be 14 minus 2, that is 12c, 8 minus 2 is 6. So 12c6 is the first case. So if 2 particular players are included, then 12c6 is the required arrangement. Okay. So if 2 particular players are always included, then the number of selection will be 12c ways. So what is this equal to? If we simplify this, factorial 12 divided by factorial 6 into 12 minus 6 is 6 factorial. So if we simplify, in the numerator you will get 12 into 11 into 10 into 9 into 8 into 7 into factorial 6 gets cancelled. Again 6 into 5 into 4 into 3 into 2 into 1. What is this equal? If you simplify, you are going to get it as this is equal to 924. If you simplify, you will get 924 ways. The first case. Now, what is the second case? So, second case, if two particular players are excluded. Case number 2. This is first case. Now, case number 2. If two particular players are excluded, then this is equal to two particular players are excluded means then 12C8. So 12C8 is the required answer. That's equal to 12 factorial divided by 8 factorial into 12 minus 8 is 6 factorial. So this is equal to 12 into 11 into 10 into 9 divided by 6 into 5 into 4 into 3 into 2 into 1. So if you simplify, what is the answer you are going to get? So if you simplify this, this is equal to 495. So these are the two cases. Two particular players are included and two particular players are excluded. If two particular players are included, you will get 12C6, that is 924. If two particular players are excluded, you will get 12C8, that's equal to 495. Now move on to the next problem. A team of conveners consisting of 4 lecturers, 4 boys and 2 girls has to be selected. So a team of conveners consisting of 4 lecturers, 4 boys and 2 girls has to be selected from 15 lecturers, 10 boys and 15 lecturers, 10 boys and 12 girls. In how many ways the selection can be made if 2 lecturers who were conveners last years have to be included and 3 boys who failed in the examination cannot be chosen. So see the condition. So a team of conveners consisting of 4 lecturers, 4 boys and 2 girls has to be selected. 4 lecturers, 4 boys and 2 girls. From how many lecturers? 15 lecturers are there and 10 boys are there and 12 girls are there. Condition. In how many ways the selection can be made if 2 lecturers who were conveners last year have to be included. 2 lecturers who are conveners in the last year is to be included. But 3 boys who failed in the examination cannot be included. 3 boys who failed in the examination cannot be included, cannot be chosen. This is the problem. Now, how to solve this? Now, let us write how many lecturers are there here. How many lecturers, boys and girls. So, a team of how many ways the selection can be made if a team of conveners consisting of 4 lecturers, 4 boys to be selected. So from total 15 lecturers, number of lecturers are 15 and how many boys are there? So 10 boys and how many girls? 12 girls are there. Okay, this is given. Now what is the selection made here? 4 team of conveners consisting of 4 lecturers, 4 boys and 2 girls. 4 lecturers, 4 boys and 2 girls. This is the selection, right? Now, what to include? Include 2 boys, 2 lecturers can be included. 2 lecturers can be included. Whereas, how many? The examination cannot be chosen if 3 boys are failed. Now, see, what is the condition given? So, 2 lecturers who were conveners last year have to be included and 3 boys who failed in the examination cannot be included. So that means 3 boys cannot be chosen, excluded. 3 boys are excluded. This is the condition given. Now you based on this just write down the required answer. That's it. Okay. So therefore the number of ways is equal to, I'll write here. Therefore the number of ways so, how many lecturers are included? That is 2 lecturers included and 3 boys are excluded, right? The number of ways is equal to 13C2 into 10 minus C, that is equal to 7C4 into 12C2. There is no change in girls, 12C2. So, 13C2 into 7C4 into 12C2. What is this equal to? So, this 13C2 is equal to 78. If we simplify 7C4, that's equal to 35 into 12C2 is equal to 66. So if you multiply 78 into 35 into 66, the required answer you are going to get is 180, 180. 180, 180 is the answer. That's it. This is how we are going to form a team, right? That's it. Now move on to the next problem. A committee of 4 has to be always chosen from 10 boys and 8 girls. In how many ways can this be done if girls are in a majority? Very simple problem for 3 marks. So in a committee of 4 has to be a committee. A committee of 4 has to be chosen out of 10 boys and 8 girls. Number of boys are 10 and the number of girls is equal to 8. So in how many ways can this be done if the girls are the majority? The majority are girls are the majority. Very simple concept. Okay. So here a committee of 4 has to be chosen. So number of to be chosen is for the majority are girls. Majority are girls. Right. So this can be done in the number of ways is equal to number of ways we can select is, so 10 boys 10 C0 into 8 girls C4 8 C4. First case 10 C0 into 8 C4 plus then next 10 C1 into 8 C3. That's it. So 10 C0 into 8 C4 plus 10 C1 into 8 C3. Simplify this. What is this equal to? 10 C0 is equal to 1 into 8 C4 is nothing but 8 factorial divided by 4 into 4 factorial plus 10 C1. 10 C1 is equal to 10 into 8 factorial divided by 8 minus 3 factorial, that is equal to 5 factorial into 3 factorial. Simplify this. That's it. What is this equal to? If you simplify this, this is 1 into 70 plus 10 into 8 factorial divided by 3 factorial into 5 factorial is equal to 56. If you simplify this, you will get 56. 70 plus 560. What is this equal to? 560 plus 70 is equal to 630 ways. 630 ways. Okay. So therefore, the required number of ways is equal to 630. Very simple problem. So a committee of 4 has to be chosen from 10 boys and 8 girls. In how many ways can this be done if the majority are girls? So out of 10 boys and 8 girls, 10 boys and 8 girls. So the number of ways we are going to choose if the majority are girls, that can be done in 10 C0 into 8 C4 plus 10 C1 into 8 C3. That's equal to 70 plus 560, 630. Now move on to the next problem. This also same type. From a class of 9 boys and 7 girls, 12 students are to be chosen from for a competition which includes at least 6 boys and at least 4 girls. In how many ways can this be done if a particular boy is always chosen? The condition is particular boy is always chosen. So here from a class of 9 boys and how many girls are there? There are 7 girls. So 12 students. How many students? 12 students are to be selected, are to be chosen for a competition which includes at least 6 boys and at least 4 girls. In how many ways this can be done if a particular boy is always chosen? Right. Now see here. So there are 9 boys and 7 girls. 1 boy is always included. 12 to be chosen. So we have to choose at least 5 boys and 4 girls from 8 boys and 7 girls. Right. Yes, see. So there are 9 boys. So there are 9 boys and 7 girls. 1 boy is always included because if a particular boy is always chosen, that means 1 boy. So 1 boy is always included. 12 to be chosen. So we have to choose at least 5 boys and 4 girls from 8 boys and 7 girls. So this can be done in 8 boys, 7 girls. So and number of selection will be, if you select 5 boys and 6 girls, then the number of selection is 8C5 into 7C6, that is 56 into 7, 392. And the second case, if the number of boys are 6 boys and the number of girls are 5, then the selection will be 8C6 into 7C5, that is 28 into 21, 588. If the number of boys are 7 and the number of girls are 4, then that can be done in 8C7 into 7C4, that's equal to 8 into 35, 220. So add this. If you add 392 plus 588 plus 280, that's equal to 1206. So therefore, the number of A's is equal to 392 plus 588 plus 280, that's equal to 1260. That's it. This is how we are going to solve. See here. So 8 boys, 7 girls. Number of selections. So let us take from this 8 boys, we are going to select 5 boys and 6 girls, that is 8C5 and 7C6, that is 392. Similarly, if we select 6 boys and 5 from 8 boys and 7 girls, that is 8C6 and 7C5, that's equal to 588. If we select 7 boys and 4 girls, 8C7 into 7C4, that's equal to 8 into 35. Totally 392 plus 588 plus 280, that's equal to 1260 Ways. That's it. Very simple. Now move on to the next problem. This is also very important. Find the number of diagonals in a decagon. The number of diagonals in a decagon. The number of sides, decagon means side. Number of diagonals. So to write a diagonal, minimum how many points are required? 2 points are required. So the number of diagonals is equal to NC2 minus N, that is NC2 minus N, that's nothing but 10C2 minus 10. What is this equal to? 10C2 minus 10. Simplify this, that's it. So NC2 minus, that is nothing but 10C2 minus 10 is, 10C2 is 45 minus 10. So the number of diagonals is equal to NC2 minus 10, that is for a decagon. So 10 sides, NC2, 10C2 minus 10, 45 minus 10, that's equal to, what is the required answer? 35. The number of diagonals of a decagon is 35. Move on to the next problem. If a convex polygon has 170 diagonals, find the number of sides of the polygon. So the number of sides of the polygon is to be determined. Okay, a simple concept and important. So there is one formula. The number of diagonals of a convex polygon is equal to, the formula is n into n minus 3 divided by 2. So here how many sides? The convex polygon has 170 diagonals. 170 is equal to n into n minus 3 by 2. Cross multiply this. 170 into 2, that is 340 is equal to n into n is n square minus 3n. So what you are going to get? N square minus 3n minus 340 is equal to 0, a quadratic equation. Solve this, that's it. Okay, so this can be factorized as 340 can be written as, factorize it, 20 into 17. 20 into 70, right? This is a negative, minus 20 into positive. So this can be written as n square minus 20n plus 17n minus 340 is equal to 0. So you can take common factor n minus 20 plus 17 common factor, n minus 20 is equal to 0. Here n minus 20 is a common factor into n plus 17 is equal to 0. n minus 20 is equal to 0 or n plus 17 is equal to 0. n is equal to 20 or n is equal to minus 17. We cannot take negative, n is equal to 20. So the number of diagonals is equal to 20. So therefore n is equal to 20. That's it. 20. Right, this is the answer. Okay. See here, very simple problem. Find if a convex polygon has 170 diagonals, find the number of sides of a polygon. See here, the number of diagonals is equal to n into n minus 3 divided by 2. Since there are 170 diagonals, so 170 is equal to n into n minus 3 by 2. Cross multiply. 170 into 2 is 340 is equal to n into n is n square minus 3n. Put it in a form. So n square minus 3n minus 240, a quadratic equation. Solve this, factorize it. Minus 340 can be written as minus 20 into 17. So 20 into 17 is equal to 340. So this can be written as n square minus 3n can be written as minus 20 plus 17 is minus 3n minus 340. Now you can take n common factor, n minus 20. You can take 17 common factor, n minus 20. In these two, n minus 20 is a common factor. N plus 13 is equal to 0. N minus 20 is equal to 0 or n plus 17 is equal to 0 means n is equal to 20 or n is equal to minus 17. We cannot take negative values. So therefore, the number of diagonals n is equal to 20. So therefore, the number of sides of the polygon, number of sides is equal to, number of sides are 20 sides. 20 sides are there to draw 170 diagonals. That's it. So this is how we are going to solve this problem. Hope you followed. So that's all regarding today's session. Let us meet with a different concept in the next session. Thank you. Thank you very much.